Okay, guys, just to check from where we left off on our last session, just to check with you. Now, if this is the center, then I drew a line here. Right, okay. Let me just draw a line. Let's see. I'm gonna say this is line A, this is line B, and I draw a line from the center to the line. Leonard, what's the name of the line AB? If you remember from our last session, what's the name of the line AB?
A chord.
Yeah, huh? So you remember from our last session, AP, it's a chord, which is 3. So now if I draw a line from the center to AP, that line I'm saying is perpendicular to AP. Now we proved a certain conclusion on our last session. We made a statement, the statement I just made now, that when a line drawn from the center to the chord, it is perpendicular to the chord. Conte, please remind me, which conclusion about all of this that is happening here did we make and prove on our last session, which was one of our theorems?
So can you please repeat?
Now, I'm saying we made a statement for it, that line drawn from the center to the chord is always perpendicular to the chord, meaning whenever you see a line drawn from the center to the chord, that line will always be perpendicular to the chord. But now let's think another statement that comes after that. And I said it's not really a statement, it's a conclusion. But that conclusion, that's why we have these theorems and you need to prove them. You can't just conclude, you need to prove the conclusion. Konje, what was the conclusion that we had to prove? And it even became a theorem that we proved. Which condition from this statement, a line drawn from the center to the chord is perpendicular to the chord? That is true because it's something we see with our eyes. It's a statement. But there was a conclusion that we had to prove about, I'm going to name this part M. But there was a conclusion that we need to prove.
That AM is equal to MB.
True, but there is a way I needed to put it in, man. Not quite like that.
AM is equal to BM.
No. That's the same thing to say. Oh, you already see you. No. There is, man. There is a mathematical conclusion. Let me write to be proved, which is something we prove to be proved. Guys, what was the conclusion you had to give?
Sarah raised her hand.
Oh, I'm sorry, guys. When I'm here, I can't see the thing. Yes, Ria.
Yeah, so that what's the letter of the point in the middle?
Let me name it for
Yeah.
you.
So it's gonna be OMB is equal to 90.
It's the same thing when I say OM is perpendicular to AB. It means OMB is 90. I, the conclusion we had to prove last week was that since the line drawn from the center to the chord, it is perpendicular to the chord. But remember, the conclusion we had to prove for this theorem was that OM bisect AM, which is true. What she just said, saying it means AM is equal to MB. But I wanted her to say this statement like a mathematics learn. OM bisect AM. If you bisect something, you are dividing it into two equal parts, meaning AM is going to be equal to MB. That is the theorem we proved. Do you remember, guys, how did you prove this? How did you prove that indeed OM bisect AM? Do you guys remember how did you prove? Can someone guide me through the proof? Tell me what to write and I'll write it throughout. Tell me what to write regarding the proof. I'll be listening to you. Can someone step up and tell me what to do?
We construct a line from O to A.
We construct
A line from O to M.
Okay. Do I draw a solid line? What do I draw?
A dotted line.
Okay. Uh-huh. After
And same in O and to B.
O to B. Okay. Then
And
after
those lines, we call them radius.
angle,
Radius. Those lines are called the radius.
it's radii. If it's two radius, if it's two of them, it's radii in plural form. Okay.
Yes. So we're gonna say OM is equal to OM, which is the common.
Why am I writing that? Why do I write OM equals to OM common? Why? Where
Because
is that?
OM is it's into those like triangles.
Okay, I understand it's common. It appears in which triangles?
Uh,
Why? What am I doing in those triangles? I feel like you just started like that. You didn't start properly. Please start from the beginning so I can understand that when I say OM, what is it that I'm doing? Why do I compare the sides? Why? Which triangles?
we are working on a triangle OMA and OMB.
We are working on them for what? What are we doing on those triangles?
We want to prove that OAM is equal to MB.
Mm. Then how can we do that? How can you prove that AM is equal to MB with those triangles? What is it that you have to do?
We have to. I think we have
Why?
to do a
What?
we have
Why am I? How am I comparing these two triangles? What am I using so that I can get to the conclusion that AM equals to MB, which is what from you I hear is what you are required to do.
congruent.
We need to do what?
Congruence.
Congruent. That's what I wanted from you. The only way, the only way to prove that AM is equal to MB, remember, if the conclusion you're trying to prove is that OM, since it's perpendicular to AB, it indeed bisects AB, or AM is going to be equal to MB. So that's what we need to prove, that indeed AM is equal to MB. So now we can construct these two radii. Since we constructed the two radii, let me admit someone into the call. Since we constructed the two radii, it means now we have two triangles. Now the sides that we are trying to prove that are equal, they are on the triangle. How do I start writing? Kunje, what do I write first?
Construct.
Construction, okay. You got a mark for construction. Let me use a different pen. Along the way, I'll be marking for you. You have a mark for construction, fine. Then what's next? What do I write first before I start my proof? From our last session, I told you start by saying required to prove that AM is equals to MD. That's what you're required to prove when you write proof. Then, now since you have to prove by using congruency, what do you write first?
The triangle that we'll be working on.
So you start by saying in triangle and say AOM and triangle BOM. So now you start. Let's start now proving a congruence. You have to prove one of the congruency requirements. Né? You have to prove at least one of them. Side angle on the side, right angle, hypotenuse on the side. So you need to prove one of them, or angle on the side. So what do we start with? What do we write? Look at your triangle. Let's start. Let's start proving now.
OM is equal to OM.
OM, and what's your reason?
Common.
It's common. Then next.
OA is equal to OB. Right.
OP. What's your reason?
Right.
Right. Okay, you are not done. Remember, congruency needs to prove three conditions. What's next?
OMA is equal to OMB.
OMA. I guess that's the angle. It's equal to OMB. They're both equal to 90. There's no reason because so now which so therefore I can conclude to my triangle AOM is congruent to triangle BOM. And what's our reason for congruency? Which condition applies? Which condition applies?
RHS.
RHS. Right angle, hypotenuse, and side. Now, where's the right angle part? It's the 90 degrees. Where's the hypotenuse side? It's the radius. This radius where hypotenuse. Where's the side part? Is the common side. Then EB.
Ini betul phone ka steady up.
Sorry. Then indeed our condition. So do you guys remember the reverse, the converse? Can someone just take the converse so we move to today's thing? I'm not going to ask you about the angle at the center twice the circumference or the one that the angle subtended by the diameter at the circumference is 90. Because I hope guys from the last session you remember those. If you forgot them, go back to our video. Go back to the video. Go back to our first session and revise. So can someone remind me of the converse? Can someone just tell me what did the converse say? The converse, remember last time when I gave the example, it was like
The conference.
if when Sana is hungry, he always fight people. Then the converse will say, if Sana is fighting people, it means he's hungry. So now the theorem, since we just proved it now, we can even improve the conclusion and say, line drawn from the center to the chord, the perpendicular. This is how we can put it. A perpendicular line from the center to the chord bisects the chord. Now we proved it. We can say bisect the chord confidently. So now, what does the convex say from that? I just gave an example, guys. Even last week I used the same example. Sana fights with people when he's hungry. The converse will be like, when Sana fights with people, it means he's hungry. So now for this theorem, since it has a converse, what's the converse from the statement and the conclusion we just proved? The perpendicular line drawn from the center to the chord bisect the chord. Now, what's the converse of that? I even wrote down the converse last week. Hey, one. Hey, one, guys. So you guys after doing the work, I didn't have a video for you guys online for you guys to like use it when you need to revise. Okay? Guys, you forgot the converse. This is going to YouTube, by the way. So you guys can, because I realize in my drive, you guys have a trouble accessing my drive lots of you. And my drive, guys, is my private space. So that's why I just put them on YouTube. Hey, guys, what does the converse say? Well, you know what, guys, it's fine. So now, the theorems we did last time, they were speaking about the center. They were evolving around the center. So now today, we're not gonna talk about the center. So many the theorems we are doing today, they do not involve a center. So we are gonna do the theorems that have nothing to do with the center. Meaning now, when you see the center in a question, you start looking for the theorems that have to do with the center. The first theorem is convex. The theorem of the diameter, remember the angle subtended by the diameter at the circumference is 90 degrees. We did it. The last one, also angle at the center is twice the angle at the circumference. And how to prove that, guys? I showed you how to prove it. I gave you work last week to send me the work after you are done writing. You guys didn't submit. Only few submitted. I gave you guys something to prove. You guys didn't submit, but it's fine. By the way, so today I want to, like I said, we're gonna speak about the theorem that has nothing to do with the center. Now, the first theorem of the day is what it says. You guys now understand the word subtend. No? You guys understand the word subtend. So now I have to introduce something beautiful that will be very helpful for the rest of the cycle to me. We are saying, if now you have a chord, remember this line drawn from one point of the circumference to another. We call it a chord. I'm going to call this guy AB. Well, most of the times I call it AB. If AB, it subtends an angle at the circumference. No. He's not the one. He's not the one. If my chord AB subtends an angle at the circumference, I call this guy X. Now, AB, the same chord, it subtends another angle at the circumference. I'm going to call this Y. Since the two angles, since this angle and this angle, they are both subtended by the same chord and at the circumference. Guys, it's important at the circumference. Whatever I'm about to say now, whatever I'm about to say about this theorem doesn't apply if the angles are not at the circumference. So, the angles must be at the circumference. We are saying angle X is equal to Y. What's the reason? You say these are angles. These are angles in the same segment. Next, remember the chord divides your circle into two segments. Where the angles are at the circumference is the first segment, then the second segment is this side. But now, this chord, those angles must be subtended at the circumference. That is very important. So meaning if you have a situation whereby this is a circle, this is a chord, one angle is subtended somewhere here in the air, the other one at the circumference, then the two angles are not equal because the other one is not subtended at the circumference. No? So now guys, remember with the chord and the arc, they work the same way. Don't be confused. Now I'm gonna have my circle and I'm gonna have these. Okay, I'm gonna have these and I'm gonna have these. Then I'm gonna name my arc BC. My arc BC works the same way as my chord AB. Arc and the chord guys, they work the same way. Don't forget, I'm gonna have alpha, I'm gonna have beta. So now note here that alpha is equal to beta, the raising angles in the same set. In maths, we are lazy guys. Usually we just use these short representations to represent our whole statement. We don't usually write out the statement. So now let's look at an example. Meaning if I have this, now I'm gonna draw my chord and I'm gonna name this guy AB again. Then have this one here. No. Drawing. I'm gonna have this guy here. I'm gonna have 30 degrees. I'm gonna have this guy here. I'm gonna have an X. I'm gonna have that guy there. I'm gonna call that guy Z. Now let's check guys. X, Z, and 30 degrees. They're all angles subtended by chord AB at the circumference. Meaning my Z is equal to my X is equal to 30 degrees. What's the reason guys? What's the reason for Z and X to be equal to 30 degrees?
Angles that are subtended by the same arc.
Now this time it's a chord. But now what's the reason I told you to write? What's the reason? Well, how do you reason this? Yes, true. They're equal because the angles subtended by the same chord and at the circumference. Very important. Very important. So now, how do you reason this? I just wrote it up there, guys. How do you reason this?
Angles on the same segment.
Angles in same set. Okay, guys. So this one, are we all fine? So meaning, if I have this and my arc subtends an angle here, I'm gonna say it's 32, and it subtends another angle here, I'm gonna say it's X. then my arc is 80. So guys, I can say x is equal to 50 degrees, né? And reason is still angles in same circle, right? Guys, are we fine?
Yes.
No, you're lying. How can this x be equal to 80? Because this x is not subtended at the circumference. Eh?
It's not.
How can is not subtended at the circumference? How can the x be equal to 80? Guys, are you listening?
Yes.
Are you sure?
Yes.
Yes, sir.
Yes.
I feel like you guys are not paying attention today. So now we're gonna speak about something called cyclic quadrilateral. Last week I defined what the cyclic quad is. What did I say, guys? During our last week session, what did I say the cyclic quad? How did I define it?
Cycle quads subtend 4 angles in the circumference.
It's a what?
And all the points are touching the circumference.
Okay. I wanted a simple definition, but the simplest one. Ria, what is
Sir,
cyclic quad? What is cyclic quad?
it's when all the points are touching the circumference.
Okay. Clone, what is cyclic quad? Clone, what is cyclic quad? Tambo, what is cyclic quad? So last week I said to you, the word quadrilateral means a four-sided figure. Cyclic means this is a four-sided figure drawn inside the circle. Okay. Now let's look at the properties of these four-sided figure that is drawn inside our circle. Number one, all vertices, the vertices, vertices must touch the circumference, like what you guys are saying. Meaning, if I have my circle like this, my four-sided figure, all the four, let me say corners, so you can understand. All the four corners of my four-sided figure, they must all touch the circumference. The first one, the second one, the third one, the fourth one. All of them, they must touch my circumference. Okay, let's continue. So now, what's the other property? The opposite angle. No, let me say interior. Opposite opposite inte- opposite opposite interior angles are supplementary. What, can someone tell me what does it mean when I say opposite interior angles are supplementary? The opposite interior angles.
But when they
Yeah, what?
add up to 180,
Yes. So what
they
does
add
it?
up to 180.
Yes, ma'am. So let me draw a circle, then draw my cyclic quadrilateral. All four vertices touching the circle. What does it mean? If this is angle A, B, these are the interior angles that inside my four-sided view. Hence we call them interior. If I'm gonna tell an angle exterior, it means it's outside. So now what does it mean when you say opposite angles? These are opposite angles, meaning if I draw X here and Y are also opposite angles. So meaning A plus B is equal to 180 degrees. What's the reason? the interior opposite angles of a cyclic quad are supplementary. And my x plus y is also equal to 180. But the reason? The reason is the interior angles of cyclic quad are supplementary. Ne? I just told that. Are we together so far?
Yes.
Yes, sir.
Can everyone confirm that yes, we are together so far?
Yes, sir.
Yes,
Okay,
sir.
okay, perfect. Now we can continue. So now I'm gonna write the last property of a cyclic quadrilateral. So now the last property, the exterior. So I'm just gonna write F because I've met people who are lazy. No? The exterior angle. Let me not say angles because I'll be wrong. The exterior angle of a cyclic quad is equal to the opposite interior interior angle. So now I'm just gonna throw it inside the circle because if I just throw a positive stick, I know you guys, some people are gonna be confused. We stick to it being a cyclic quad as per the definition. So I'm just gonna draw my circle and now I'm gonna draw my four-sided stick and making sure that all the four vertices are the circumference. So now I'm gonna draw the exterior angle outside the four-sided stick. So now what does it mean when you say the exterior angle of a cyclic quad equal to the opposite interior angle? It's equal to the second interior angle, but which one it is? Is it this one? No. This is not opposite to my angle, to my exterior angle. So it has to be this angle. So now you kind of have an idea of what the interior opposite or the exterior with the interior opposite to it, how does it look like? I won't take problems. Meaning if this is 30 degrees and this is my x, meaning my x is just going to be 30 degrees. Don't confuse the angles that are supplementary, which are the interior opposite ones, and the exterior angle being equal to the interior opposite one. Just don't confuse the two. So don't confuse the second property and the third one. Are we together, guys? So now we check. You're gonna be asked to prove that the figure is a four-sided figure. Let's check. Which of the properties can you prove? Can you prove that all the vertices touch the circumference? No, you can't. You can't prove that in writing, but you can prove the last two properties. So meaning if you are asked to prove that something is a cyclic quad, you're either gonna prove that the opposite interior angles of whatever the four-sided figure is are supplementary, or you're gonna prove that the exterior angle of that whatever shape, whatever four-sided figure it is inside the circle, the exterior angle is equal to the opposite interior angle. Why do I say whatever the figure is? Because you're still yet to prove. It's not a cyclic quad yet. It's a cyclic quad after you have proved it. So now guys, another thing that students usually don't get. Let's say you have something like this. Typically in Euclidean geometry things. Like kuhlanga guys. Let's do something like this. So there is a four-sided figure in the chaos here. It's called ABCD. No? They say prove ABCD is a cyclic. We're gonna do questions with honor. I'm gonna be honor in the session. We're gonna do questions with you guys. So now when they say prove ABCD is a cyclic quad, check. I'm gonna use a different pen. You can prove that this angle right here plus this angle is 180. You will have proved that the interior opposite angles are supplementary. Or you will have proved that this angle here and this angle here is 180. Same thing, you will have proved that the interior opposite angles are supplementary. When I say supplementary, I mean they add up to 180. Or you can prove that this exterior angle here is equal to this exterior, the opposite interior angle, which is this one. Or you can prove that this exterior angle here is equal to this opposite interior angle. Or if you can check the exterior angle here, is divided by a certain line. Or if you have to find this Bologna angle plus this angle, These angles, both of them, two of them, you can see they make the exterior angle. So you must solve for them individually. If you don't have the real of them combined, they're gonna be equal to these opposite interior angles. So guys, are we fine with the properties of a cyclic quad? And now you know which ones you can be asked to prove.
Yes.
Are we sure, guys?
Yes.
Yes, sir.
Where are you confused? Are you confused about what the properties say, or by the way, guys, to prove cyclic quads, you must know all your theorems so that you can be able to determine a value of angles using the theorem. So meaning every theorem that we do, you must listen carefully and make sure you understand. Guys, these videos are gonna be there out there for you. These are your sessions, guys. You own them. So after this session, I upload it on YouTube. You're gonna go there and watch again in class so you can understand. The person who said they don't understand, can you please tell me which part do you understand? The properties themselves, or how? Who said they don't understand, guys? Oh, one thing I forgot to mention to you. Once you prove, you see this figure here, it's in a lot of chores. Let's say you are done proving that it's a cyclic quad. What do you do on your question paper? You take a pencil. One thing that you know, there is no circle around this thing, but they ask you to prove that it's a cyclic quad, but there is no circle around it. What you should do, you take a pencil after proving that it's a cyclic quad, you draw a circle, making sure that the vertices of this thing, they touch your circumference. You draw a circle around it like this. After that, all the properties of the circle, they apply inside that circle. The property or the theorems, they apply. I don't know if you guys understand me. So you might find out that there are angles in the same segment inside the circle you just drew. But whenever you prove that the figure is a cyclic quad, even though there is no circle around it, well, 98% of the time, the four-sided figures they ask you to prove if they are cyclic quad, there are no circles around them. After proving, you know that the cyclic quad, it must have a circle around it, and all the four vertices, they must touch the circumference of that circle. Then after all the circle, the circle theorems and properties, they apply now. Are we together, guys? Guys, I'm moving on because the person who said they don't understand, now it's quiet. I don't know what's going on. But rest of you guys, are we together?
Yes.
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 Okay. Okay. Give me a second. Okay. So now if you understood that, we're gonna go to tangents. We're gonna go to tangents. On your last week, guys, when I was explaining a tangent to you, what did I say? Guys, last year when I was defining a tangent to you, what did I say? Oh, well, guys, come on. Last week, when I was describing a tangent to you, what did I say, guys? What did I say is a tangent? Guys, did you attend last week? Guys, what
No.
did I say? Why didn't you watch the video? Because attending is if you miss a class, it means you watch a video now. Did you watch the video?
No.
Yeah.
So tangent
Why
only
didn't you watch the video since you missed it? I'm sorry, I didn't catch that. Sorry, can you repeat?
I
Before tangents, wait, wait, can you wait it? Before tangent, I'm gonna forget to prove this, to do you this too, because they love bringing it in an exam. So I want us to do before we move from set the quad completely, I want us to prove that indeed the opposite angles of a circuit quad they add up to 180 degrees. Yeah? So now remember, with our proofs, we have statement and a conclusion here to prove. The statement is why does it turn it into the statement is the opposite interior angles are supplementary. No? Right guys? The state I don't know why this thing is turning my things into and now I can't delete give me a second. I don't know why it's turning them into okay. So my statement, let me rewrite my statement. I apologize for that. My statement was now we said the opposite interior angles of a cyclic quad are supplementary. Kunje, what does it mean again? Can someone tell me what does it mean again?
they add up to 180.
Yes. So now let's prove that before we move to tangent so that I won't have to go back and you guys don't get confused. Because if I move from this to this and I have to go back to that one, you guys will end up being confused. So now we are doing the proof, which is our third proof from a third proof. We did two proofs so far. Next, so this is our third proof on the third theorem. Some theorems we didn't have to know the proofs, but some have to know. So I'm just gonna draw a cyclic quadrilateral, meaning all my vertices must have the circumference. No. Meaning all my vertices they must have the circumference. So okay. Perfect. Now it is. By the way, guys, something as long as it has one of the properties, it doesn't have all the properties. It doesn't have to have all the properties. If you can prove only one property, either if you can just prove that the opposite interior angles are supplementary, or the exterior angle is equal to the opposite interior angle, as you are done, you just have to prove one property. Guys, when now you are required to prove that these opposite interior angles are indeed 180. We have to go back to the theorem that we just did. You remember that theorem, the second theorem about the center. Angle at the center is twice the angle at the circumference. We need help from that theorem to be able to prove these theorems. So you see now, you have to understand that theorem. So now, since we need the help from a theorem that involves the center, we must bring back the center. I'm going to bring back the center here. I'm going to name this guy O. Are we together, guys? So after naming this guy O, we need to do what we call constructions. Meaning you need to okay, first before construction, let me name my thing. I'm gonna say this is A. Why is it so thick? Let me reduce the thickness. Then I'm gonna reduce the okay. So I'm gonna say this is my A, then I'm gonna say this is my B, this is my C, this is my D. Next, then my O, the center just got its O. Why am I bringing the center? Remember, I'm trying to seek help from the theorem about the center that we just did, you and I. So I assume everyone knows the theorem because we did it. So what do I do? Remember, first thing first, when you prove a theorem, from the theorems we did, this is something I told you. You must do your construction first. So now for this theorem, what are we constructing? We need to construct radius. From A, then I'm going to construct the dotted lines to O, then I'm going to construct again to C. Are we together, guys? Then this side, I'm going to name it 1, 2. Then this is going to be O1, and the other side is going to be O2. Né? Everyone, are we together?
Yeah.
We're done.
Yes,
You got a mark for construction.
yes.
Yeah. This pen disappears. Yeah. You got a mark for construction. So now remember, when you what is this? When you prove, Gonja, what's the first thing do you write? Yeah, guys, you write required to prove. So you're required to prove that angle D is equal to angle B. No, not equal. I'm sorry. Plus, supposed to be plus, supplementary. Plus, angle B is equal to 180 degrees. And you're supposed to prove that angle A. Guys, if you understand the proofs in my classes, you won't have to worry about proofs anymore in Euclidean. I'm gonna do the last part of Euclidean that I'm gonna do, which is gonna be part 4. I'm gonna do part 3. Part 4 is gonna be for only grade 12. We're gonna be doing proofs like your similarity, your proportionality, all of those. If you understand all my proofs in my classes, you pay attention. You won't have to go. You won't have to go crazy over these proofs. You are sorted for Euclidean proofs. Whatever proof that comes, you get your 6 marks and you clear out. Actually, for the Euclidean, we're gonna do questions. So last sessions we'll be doing questions with honor which will be there. So 180 degrees. So we are required to prove that angle B is equal plus angle B to 180, along with C plus angle C equal to 180. Remember, this comes from one of the properties. We need to prove if the property was true. Whoever who researched and found that out about the property was he right. You know, that's what you're supposed to prove. You did your construction test, then you write is required to prove. Are we together, guys?
Yes.
Yes, sir.
So, guys, from the proof that we did, if you understood, do you agree with me when I say angle O1 is equal to twice angle B? And what's the reason? From the construction now.
Angle,
Yes,
angle at the center 2 times angle at the circumference.
yes, that's true. And you know how to prove that theorem, ne? From our last class, you know how to prove that theorem, ne?
Yes.
Yes.
Angle at the center is equal to 2 times angle at circumference, ne? Everybody,
Yes,
are we
sir.
fine? So, guys, do you agree when I say O2 is equal to twice B for the same reason? Do you agree? Do you agree that this angle is also at the center is equal to twice this angle?
Yes.
Okay. I'm happy there. Angle at the circum is equal to. Guys, I don't recommend missing our classes for any topic. For grade 12 and 11, guys, I'm gonna cover all your topics. All your topics. So before you write your June exam, I will have covered all your math topics and making sure you're sorted and great. You know, I wanna do the same thing with physics if I have time. Because physics, I'm focusing on grade 11 now, but when I have time, I'm gonna try to cover both grade 11 and 12 topics. Your physics is only similar with Newton's laws and matter and materials. The rest of the things are not the same, but I'm gonna see how I'm gonna I'm gonna sort that one out. But with math, I want to cover everything for 10 to marks. So I don't want to see level 3, level 2 in math if you attend this extra lesson. Nah? Are we together, guys?
Yes, sir.
Okay. So let's do this. Let's add angle O1 plus angle O2. It's equal to angle equal to 2D plus twice B. Do you agree with me?
Sir.
Do you agree with me, guys?
Yes.
Yes.
So I can say O1 plus O2 is equal to 2. I can take out 2 as a common factor, then it's going to be into B, angle B plus angle B. Are we together, guys?
Yes.
But let's do you agree that O1 plus O2 is equal to 360 degrees? Let's go back. O1 and O2, it's angles round the point. You see, it's angle round the point. Do you see that, guys?
Yes.
Can everyone
Yes.
confirm? Because I only hear one person confirming over and over. Can
Yes,
other people?
sir.
So you see that O1 and O2 is revolution. Another way of saying it is say revolution. You see that O1 plus O2 is 360. So meaning since O1 and O2 is equal to 2 into D plus B, 2 into angle D plus angle B, I can say 2 into angle D plus angle B is equal to 360 degrees because it's equal to O1 plus O2. Are we together, guys?
Yes.
Yes.
So if I divide by 2 both sides, angle B is plus angle B is equal to 180 degrees. I'm done proving that angle G plus B is equal to 180. So far, is anyone confused?
No. No.
No one is confused.
No.
Guys, is anyone confused?
No. No.
No, sir.
No.
Okay. Please confirm with the voices. Yeah? So now, let's check. We just proved it. We just proved the first part. We just proved this. We haven't proved that A plus C is 180. But the sum of angles in any quadrilateral, guys, any four-sided figure, how much is it? Guys, the sum of angles in a quadrilateral, whether it's a square, it's a rectangle, as long as it has four vertices, how much?
306.
306. Since now we proved that D angle D plus angle B is 180. Since the sum of angles in a quadrilateral must be 306, oh, it means angle A plus C are also 180 because it has to be 180 plus 180 and be 360. Therefore, you can conclude and say, therefore, angle A plus angle C is equal to 180 degrees. What's the reason? Sum of angles in a quad. We are done with the proof. You get your 6 or 7 marks. What the proof had, guys?
No.
No.
So you can prove it anytime, ne?
Yes.
Okay.
Yes.
Now I'm coming to the question I had for you. Tangents. Now we're gonna deal with tangents. By the way, we're almost done with the proofs. After this lesson, we're gonna do questions the next one. And the other one, I'm gonna be doing the 12 with video. The things they added, the theorems that are added in the 12. So I asked the question, guys. What's a tangent?
A line that touches the circle once.
Can someone answer? Because I feel like you've been answering. Can someone else answer?
A line that touches the circumference only one time.
Only one time. And where? Inside the circle, outside the circle.
Outside.
If I continue, how many new learners are in the session right now?
Sir?
How many new learners are in the session? there any new learner?
Yes.
Who is it?
Sir?
Who is it? Who am I speaking to? Oh,
Slelokuhle.
oh, okay. Oh, you're the one who's answering all along. Are you the one who's been answering?
No.
Okay. Who's been answering, guys? There's someone who's like really answering. Who is it?
It's me, Sir Ashley.
Ah, thank you so much, AC. So now tangents, guys, like they explained, this is my circle. They are drawn outside the circle and they only touch the circle only at one point outside the circle. So I'm gonna name this guy AB, and the point of contact I'm gonna name it N. Ne? So before that, I'm gonna go back to bringing my center. I'm gonna bring my center. Okay, remember guys, a line drawn from the center to the chord was perpendicular to the chord. You remember that? So now it turns out that when I draw a radius to the point of my contact between the tangent and the circle, radius will always be perpendicular to the tangent. Are we together, guys? So, meaning even if it's a diameter, let's say it's a diameter from here, where is the diameter or radius? But the radius will always be perpendicular to the tangent. Are we together, guys?
Yes.
So
Yes.
meaning here, let me say OM, meaning here, my radius OM is perpendicular to my tangent, tangent AMB. Are we fine, guys? So guys, remember, what is the diameter? Diameter, guys, and radius, it's the same thing. It's just now the diameter is twice the radius, but same thing. So just note that the radius or a diameter is always perpendicular to your tangent. You learned one property for the day. Are we together, guys?
Yes.
Yes.
Another property about, guys, these things, when we do calculations, when you solve problems, you're gonna need them because the next step is for you to understand the basics. When I solve, I don't want to be saying, okay, guys, now in this point, you can see that the tangent is perpendicular to the radius is 90 degrees, and you ask me why. I don't want it to be that way. So now, let me draw a circle. This time I don't need this time I don't need a center. No? So now I'm gonna draw this tangent from this point to somewhere here. I'm gonna draw this tangent from this point to somewhere here. So I'm gonna have AB, I'm gonna have CB. Okay guys, let's check here. I have two tangents. They are drawn outside the circle. We are saying these tangents, they are drawn from the same point outside the circle. They are both tangents to the same circle, and they are drawn from the same point which is point B outside the circle. We are saying therefore AB, tangent AB is equal to tangent BC. What's the reason? These are tangents from from the from the same point. Is it hard, guys?
No.
No.
Easy, ne?
Mm.
So far,
Yes.
tangents are going fine, ne?
Yeah.
Yes.
Okay. So
Yes.
if the tangents are going fine, we come into the mega theorem of tangents. Let me call this guy mega theorem. Mega theorem of tangents. I'm gonna call this guy mega theorem of tangents. What does it say? This is, I will need you to pay attention. The first two, don't forget them. Don't forget the first two. Ne? You don't need to prove these. That's why I don't actually categorize them as theorems. You don't need to prove them. You just have to know them by heart. So now, let's come to the mega theorem of the tangent. I'm going to draw a circle. By the way, guys, I know you guys, this is the last one. After this theorem, we are done with the circle geometry theorems. We are done with circle geometry. What's going to be left, guys, is to do problems after problems. So next session, which is part 3, it's not even part 3, it's just questions. You and I are going to be in this session solving problems, repeating geometry problems. Then the session that's going to come, the last session, I'm going to do proportionality theorem, which is grade 12. Next, I'm going to do proportionality theorem, which is the grade 12 one, and similarity theorem, and Pythagoras theorem. So those ones, grade 11s, will not come to them. So now I'm going to draw a tangent outside. I'm going to name this guy A, B, then I'm going to name the point of contact with the circle C. I'm going to draw a chord. I'm going to draw a chord. Okay, let me do this. Yeah? Let me do this. So that you can see the different. No, this one is. I'm going to draw a chord. I don't know, this color sucks. By the way, can you see the chord, guys? I'm going to draw the chord.
Yes.
Okay. Is the chord perpendicular to the tangent?
No.
Yes. Why? Because only a radius or slash diameter is perpendicular to the tangent. A chord, a normal chord, is not perpendicular to the tangent. So now let's find out about the relationship between the normal chord and the tangent. We are saying when the chord is drawn from this point of contact between the tangent and the circle, and this very same chord, it subtends a certain angle at the circumference. Guys, that's very important, at the circumference. We're saying the angle that the chord makes with the tangent, I'm going to name it alpha, is equal to the angle that the same tangent, the same chord subtends at the circumference. So I'm going to call this guy MQ. So let me repeat. The angle that is made by the chord, this chord, MQ, this chord, the angle that is made by this chord, MQ, and the tangent AMB, is equal to the angle that the same chord MQ subtends at the circumference of that circle, meaning your alpha must be equal to your beta. When you write the reason, don't worry, you just write Tancourt theorem. Your reason is just Tancourt theorem, which is what we are going to prove, you and I. The statement is, this chord makes an angle with the tangent, which is AMB. And this very same chord, it subtends a certain angle at the circumference of that circle. That's the statement. Now, the conclusion you have to prove is that indeed those angles are equal. That's Tancourt theorem. Does everybody now get the Tancourt theorem?
Yes.
Yes, sir.
Yes, sir.
So now, if I have, let's check. If I have my circle, and I have my tangent, and I have these. This is 30 degrees. And I'm gonna name this X. And how much is X, guys? Oh, wait. I need to make this sweet. You guys are making me doubt. I feel like you don't give up. Wait, I mean, you don't focus. Ah, I'm gonna name this. I'm gonna name this A, B, C, D, E, F. Guys, what's the value of X and what's the value of Y and what are the reasons? Guys, if you were focusing, say, what are the values of the two variables and what are the reasons?
Angle Y is equals to 40. Angles in the same segment.
Oh, thank you so much. Yeah, thank you so much. Angles in the same sec. Which chord subtends them? Which chord subtends the two angles for them to be in the same segment? We see there's no arc, so it's definitely a chord. Which chord? Oh, come on, guys. Which chord? Guys, you need to pay attention. And when you don't understand something, you stop me. Guys, you can't recognize a chord now that subtends to the two angles.
BD.
BD.
Thank you. Why were you quiet? Then how much is X and what's the reason? Guys, how much is X and what's the reason? Yeah. Guys, what's the what's the reason angle X is equal to whatever it is? I want you to tell me what angle X equals to. Guys, I hope. I don't know. I can tell you something right now. You guys don't know why X is equal to 40.
Tanquart theorem.
Tanko theorem. Yeah. Then the answer is Tanko theorem because BD, which is chord, makes an angle with this tangent, it's X. Then you check. Now you follow the angle that the same chord subtends to the circumference. I can see that angle is 40 here at the circumference. There it is. So it's 40. Answer is Tanko theorem. Okay, let me ask this because you guys now are really discouraging me. I'm not getting it down here. Control T. No, I opened another browser and leave 15. Cloney, is it the way I teach? You guys don't understand the way I teach. One delay. Is it the way I teach?
No, sir.
No, sir.
I don't know because you guys seems like you don't understand. Rhea,
Sir.
is it the way I teach?
No, sir, you're fine. I understand.
Mara, why are you quiet when I ask a question?
Yes.
Indogute.
Sir.
Is it the way I teach?
Sir.
Eh? Lunch, I'm surprised when you guys don't answer. It's actually concept theorem. Now let's continue. So guys, this is another theorem that has a converse. Ne? This is another theorem that has a converse. So now it means okay, when we say when a tangent makes an angle with the chord and the chord subtends that as another angle at the circumference of that circle, the two angles are equal. The reason is chord theorem. Ne? So before the converse, ne? We're gonna prove the theorem. Then after proving the theorem, I'm gonna be satisfied for now. Yes, now we are done. So before proving the theorem, I want to give you this. Before proving the theorem, I wanna give you. Can you guys solve for x first and tell me the answer? And explain with reason. I'm giving you 2 minutes. The session must end in 10 minutes. So can you guys solve for x and tell me what's the answer? I'm giving you until 10 past 10. By the way, guys, you can't forget fun, your corresponding angles, your co-interior angles, your alternative angles, your vertically opposite angles, all those, you can't forget them. Because those are prerequisite, that's a prerequisite knowledge for Euclidean. Guys, do fast so we can prove. Yeah, a minute left. No, 2 minutes left. Please be fast and tell me what the answer. Okay, guys. So now I want your suggestion. I have 3 ways to prove this theorem. Do you want me to show you all the 3 ways, or I shall just show you one way and we stick to it?
One way.
Okay. Then we stick to that way.
Yes.
Yes.
A simpler one or a complex one? Maybe you want to challenge your mind.
Simple.
A
Say.
simpler
Oh,
one.
it's a simpler one. I thought you want to challenge your mind. Then.
Awa.
And guys, grade 12, the reason I want it in this class, the things they added in grade 12 in here, it's only 2 theorems that are possible. And those 2 theorems, they might not even bring them in an exam. They bring the second geometry theorem. And they love time cost. The theorem I'm about to prove for you now, they love it. So all the theorems, you must know them by heart. And when I ask questions, guys, this is the last session where I ask questions, you guys keep quiet. You do that next time I leave the session. True. You do that next time I leave the session. Okay, guys, how much is X? Guys, how much is X?
160.
160. Okay. She says 160 degrees. Let me circle it here. Now let's start. I can see if there is a tangent. I can see if CD is a chord. Ne? So an angle that is made by CD and the tangent must be equal to the angle CD subtends. CD doesn't subtend any angle. CD doesn't subtend any angle. Are we together, guys?
Yes.
Yes.
CD doesn't subtend which angle? CD doesn't subtend. This is just a cyclic quad. And this is simply C plus A. That's equal to 1/8. You write the reason. Opposite angles of a cyclic quad are equal. Then C plus X, X plus A is equal to 108. And X is equal to 108 minus 8. That's it. There's nothing you can do. There are no other angles here. That's it. It's just 180 minus 8. I knew if I do this, someone is gonna assume or is gonna interpret it in a way. But thank you for the attempt. I really appreciate it. Thank you for trying. So now let's prove our end. Remember, when we prove, we have what? Concha, when we prove, we have what and what? We have a statement and a what?
Conclusion.
Reason.
Conclusion. And which one are we proving between the statement and the conclusion? Guys, which one are we proving between the conclusion and the statement? Guys, which one are we proving between the statement and the conclusion?
The statement.
You're proving the statement. No. This session. No. So our statement was the one that says the angle between um a tangent and the chord. There's an angle between a tangent and the chord, and there is also an angle subtended by the chord at the circumference. That's the statement. There's no need for me to write it down. It's gonna consume a lot of time. That's the statement. So now I'm gonna draw my chord here. I'm gonna draw my chord. I'm gonna name this guy AC, and I'm gonna say it subtends a certain angle here. So I'm gonna name this guy. Sorry. Do you guys want this document at the end of the session?
Yes.
Ne? So now when I prove, what's the first thing I do? Guys, when I prove, what's the first thing that I do? First thing when I prove, what is it that I do?
You write that you are required to
No.
prove.
That's not the first step.
You construct.
Thank you.
Oh.
You do your construction and you get them. Alright guys, when you're writing in your test or exam, you need to redraw. We need to redraw whatever they gave you, whatever theorem they ask you to prove. So now the conclusion we need to prove here is that indeed the angle made by the chord and the tangent is equal to the angle that the same chord subtends at the circumference. That's the conclusion that we need to prove. First thing we need to do construction. How do you do construction? So now, remember we borrow the theorems. So we're gonna borrow. Remember when we were proving that the interior angle of your cyclic quad was 8, we borrowed the theorem from the center theorem. Again for this one, I tell you guys said I shouldn't do all the three theorems. Well, I mean all the three proofs. This theorem has three proofs. You choose A. Number one, all the and all the proofs you borrow those center theorems. So now, even for the first one that I'm gonna use, you guys said I should use only one theorem and stick to it. And this one, that I'm about to use right now. It borrows a theorem from those center theorem. Meaning I'm gonna locate my center here, I'm gonna call it O. What do I do? My construction, now I'm doing my construction. Pay attention. From A here, the point of contact between the center and the tangent. So I'm gonna construct diameter. Careful. I mean important. I must construct my diameter. After constructing my diameter, I construct a line from here to here to the other point of the chord. Did you see, guys, what I did, ne? Guys, did you see what I did, ne?
Yes.
So now, how much is this angle? The whole of this angle. And what's the reason? Let me use a different color. You guys are failing because I can't be tutoring you, teaching you, and after I ask you the things you don't know, it's actually wrong. Because after every session, you must go through them again. That's why I have these videos for you. You go through the work again. Now, this angle, the whole of this angle, I'm indicating it to you. How much is it and what's the reason? We did this theorem. It's a theorem. We did it, you and I. It's there in the video. Last session we did it. How much is that angle? Guys, how much is that angle? And what's the reason? Yeah. Yeah. Now I'm asking myself if it's even worth it. So now, since I did constructions, my angles are getting divided. But these angles, now I have many angles divided because of the construction. But I know that this is 90 degrees. The reason is that my radius must always be perpendicular to my tangent. If I asked you this, you will have kept quiet. So I'm just gonna say this part is 1 and this one is 2. Right? These angles are divided, but both of them, when they add up, it's it's 90 degrees. Because remember, my radius is always perpendicular to the tangent. I just showed you up there. But I know if I ask, you guys are gonna keep quiet. This is 90 degrees to this angle in the semicircle, because this is the angle subtended by my diameter at the circumference. The diameter I just constructed. So this angle C is always divided into 1 and 2. Are we together, guys? So when you prove, you must do
Yeah.
this application too. Are we together?
Yes.
Yes.
Yeah. Okay. So now, you're right. Required to prove. This is very important. This is very, very important. This time you're required to prove that A1 is equals to angle D. Yeah? You see where A1 is. So now, let's start. A1 plus A2 equals to 90 degrees. What's the reason? Kevanna. A1 plus A2 is equals to 90. What's the reason, guys? Why is this? Why is this 90? Guys, I'm gonna leave the session. I'm no longer playing. Why is A1 plus A2 90 degrees? I can't tell you a reason 2 seconds ago and you forgot. Ria? No, literally. Guys, why is A1 plus A2 equals to 90? Evan. Cut your tongue. Hey, why is A1 plus A2? Why is the whole A, like not the whole A? Why is A1 plus A2 equal to 9? I literally wrote an answer on top of the diagram and I gave you a reason. And we just did it 2 seconds ago. Evan. So guys, this
Isn't it perpendicular to radius?
then why were you quiet?
I thought it was the diameter until I looked at the diagram once again.
Even if it's a diameter, it's still the same thing. Diameter, radius, it's always perpendicular to the time. Isn't it what I said when I was still explaining it? Didn't
Yes,
I
you
say
said
that?
it. You said it.
Why are you guys quiet?
Still looking at my notes.
A1 plus A2 is 90 because I say, guys, I just told you this definition 2 seconds ago. Up here, I did this here. I even explained it. Here it is. Radius and a tangent are always perpendicular. Whereas the radius or a diameter, but it's always perpendicular to the tangent. I did this 2 seconds ago. 2 seconds ago. And you guys now don't even know. You're quiet. You're blank. It tells me, guys, wherever you're sitting, you don't even have a book. You don't write notes. You don't do anything. You're just staring at the screen. It's not gonna work out like this. I don't sacrifice so much of time to teach you guys math just for you to stay this. I teach you math because your math grades are not looking good at all. They're not convincing. I don't even teach you math in Shitu. You know that I teach physics grade level. I only hold these extra classes so I can give you guys an extra support. Look now in the session. The people who are failing are not even here. Look at this. The people who have been failing, they're not even in the session right now. And you want to tell me, oh, this is a kind of a session I'll have to upload on YouTube. I'm going to take it as it is. I have no choice. The people are not here. The people who are failing maths, the grade 12s, the grade 11s, they're not here. All of them. You guys are in the session now. I feel like you're just looking at the screen. You don't even bother. You don't even bother to try to like take notes. Whatever I teach you, take notes and understand it. You're like, oh, we passed. As long as I pass. I'm always teaching you guys maths. I teach you guys maths. Crash is teaching you guys maths. And you guys are giving me silent treatments during the session. I can't tell you something 2 seconds and you forgot. It's actually frustrating. Not for me, but for anyone. Any teacher out there is frustrating. Because I can tell you something right now. After 2 seconds, you can't answer. You just keep quiet. No. Guys, no. Because if it's like that, I'm just gonna tell the tutors, don't teach them maths. Yeah, fun is not working out. Leave maths. They learn maths at school and whatever, wherever they learn maths. Don't teach them. Because guys, I can't explain something now. Because in my sessions, I don't mind you stopping me and asking me to start over. If I'm done with the proof of a theorem, you can say that, start afresh, that theorem. Start explaining that theorem from scratch. I'm gonna do so. I'm not gonna pass. I'm not gonna refuse. I'm gonna explain the theorem from scratch. But at this rate, I don't see progress. I'm scared. Because it feels like I just wasted my time today. Time is always perpendicular to tangent. Tangent is always perpendicular to radius. No. We're not gonna work like that. I'm sorry. That since A1 is the angle of interest, I need you are trying to prove that A1 is indeed equal to angle B, which is the angle AC subtend at the circumference. So now I'm just gonna say my A1 is fine, it's equal to 90 minus A2. I want us to leave this for now. So guys, let's check. Do we agree that, let me name this guy E. Do we agree that EC ECA is equal to 90. Can someone tell me the reason? Why is ECA equals to 90? This angle C, this C1 plus C2, this is the angle CE, ECA, this is the angle bring up. What's the reason?
Angle in a semicircle.
Yes, angles in the semicircle. Fine. So now, wait guys, are we together so far?
Yes.
Are we together so far, guys?
Yes.
Yes.
Please respond fast. Therefore, I can do this. Okay, let me scroll. Okay, right. So, do you agree? Do you agree when I say my angle A2 plus angle E is equal to 90 degrees? Do you agree? Since this one is 90, EAC is a triangle. We already said ECA, this angle is 90. Therefore, 90 plus the remaining 2 must also be another 90 because the sum of angles in a triangle must be 8. Since this one is already 90 alone, meaning A plus B must make up the other 90. Are we together?
Yes.
So this one is kind of sum of angles in a triangle. Let me continue my proof here. Guys, so far we're together.
Yes.
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 Okay, so now from this I can say angle E is equals to 90 minus A2. Ne? Fine. Okay. Up here I say I got something like A1, where is it? Okay. Let me. Okay, guys. D. Why do I take D from? I didn't name it D and name it C. I'm naming E. E is equal to 90 minus A2. Guys, you guys are scaring me because I feel like I can say things and you guys, it just go over your head. So now, from this, we can agree that angle E is equal to angle A1. They are both equal to 90 minus A2. You can see here A1 is 90 minus A2 with different, well, we use different theorems or different ways to find both of them. And it turns out, well, they're both equal to 90 minus A2. So I can say my angle E is equal to my angle A. Where is E? No, not A1. I'm sorry, here it's supposed to be A1. So it says to me, this angle is equal to this angle. Are we together, guys?
Yes.
A1 is
Yes.
equal to E. It's equal to A1 is equal to E. But we want to prove that, yeah, we want to prove that A1 is equal to D, not E. Moreover, the only way to get there is to find a way to prove that E and D are equal. Check. Guys, are E and D equal? Guys, is E and D equal? Guys, is E and D equal?
Yes.
What's the reason?
Angle in the same segment.
Thank you so much. Who answered?
Ashley.
Ashley, thank you so much. Thank you so much. Angles in the same set. Oh, okay. Since E and D are equal, therefore angle B is equal to angle A1 because angle B is equal to angle A1 because both of them are equal to angle E. Guys, your proof is done. You carry a 7 or 8 marks home. And just like that, ladies and gentlemen, second geometry is done. Circle geometry is done. What's left now is for us to answer questions using all the theorems we use. All the from part 1 that I already uploaded to today's part. So this document is gonna go to, I don't know what you guys are gonna use the document for, but it's gonna go to, I'm gonna send it on WhatsApp. So this theorem is done. Even though you guys disappointed me. And how do you feel after finishing the grade 11s, by the way, you guys are officially done with Euclidean. Oh, issue two. What's left is for you. I know some of you didn't do it at school. Did you guys do Euclidean at school?
No.
So now you officially have a head start in Euclidean. When you do questions, that's when now you understand. But guys, please, when you do these things, try to, even now, guys, you can go and try questions on your own. When you try questions on your own, send me questions. Like, you understand? Send me. Don't just relate to yourself. You guys did this before. Nah, it was a revision. Whatever you didn't understand before, I expect you to have understood it this time. Do revision, man. Send me, I'm your brother, guys. Not your tutor, I'm your brother. Send me questions. Ask me to solve questions with you. Let's solve questions together. Video call me. Ask me to do some problems with you. You know, when I'm free, like in the evenings, I'm free usually from 7. For 7, I'm back from work. I'm here, I'm sitting on my table doing my stuff. Video call me. Let's talk about these things. Guys, am I clear? I don't want you guys missing things along the way. It's gonna be a problem. It's gonna be a problem. Because now you miss something here and now it's a whole lot of problems. So grade 12, I will say Trash is gonna do this. She's gonna do it again from the scratch with you guys. Oh no, I was still gonna host another class. Now I finished the topic with you guys. So or you have all the support, like all the support, or everyone is supporting you. Physics, I'm gonna host Newton's law stuff again for grade 11 and 10. I mean 11 and 12. So it's gonna hold Newton's laws revision. I'm not someone. Andy is gonna hold Newton revision class, grade 11, 12. Oh no, and not on. Not on. Yeah, both me and Luisa. So guys, you have all the support because Luisa now get Andy. So I'm always with her in person. All we do most of the time is talk about you guys. What? We even became friends from talking about you because we want what's best for you. But you guys, I feel like after the session, you just flip it off. You just go to bed. Like when I said, like now, guys, since I told you the whole ingredient now for grade 11, grade 12, we need to do 2 theorems only. I just need to teach you proportionality theorem, similarity theorem, how to prove them. The Pythagoras theorem, I'm only gonna teach you how to apply it. It's done. Those things are gonna take 1 session. Done. We are done. We are done. You guys is even gonna take just an hour. Done. Then we're finished with Euclidean. The whole Euclidean is done. Then now you guys are gonna do grade 11s and both of you and grade 12s. I expect you to start doing questions. Final exam, I want to see 100% in Euclidean. All the hard questions, you guys being able to analyze them. You see, guys, I love physics more than maths, but now I tutor you guys maths because now you are my siblings and I have to be here. I don't disappoint when it comes to my siblings. I want to always be there for you, no matter what it takes, guys. So you guys are disappointed today, I don't know, guys. Maybe we'll speak about it because next session I don't want it kind of silent. By the way, this video is gonna go to YouTube. You guys can watch the revision there for the whole Euclidean. And if you have questions when you're watching the video, you can ask. If you need a one-on-one session, maybe answering questions with me one-on-one here on Google Meet, you can come. You can request that. We can come together here and start answering questions together regarding the topic. And I'm gonna host another class, but before that, I'm gonna host analytical class. That is like probability. I'm gonna host them. Probability, I'm gonna even make 3 classes. Probability is gonna be grade 10 to 12. Then grade 12, probability, the only new things is it's creating the pathway, factorials, a number of arrangements, and stats, statistics, same thing. Finance, same thing, but it's just now in grade level. You guys are starting with a timeline. The timeline is gonna go to grade 12. Ne? Now in grade 12, they do things like inflation rate. They just add them there. So those topics I'm gonna be mixing you guys, and I'm gonna make sure you pass them. So this year, if you don't get a distinction in maths, I don't know, guys. It just hasn't been this. Like the people who are not in class right now. But if you attend every class, I expect a distinction from you because I want you to bother me and ask me questions. But only if you attend my classes. Because if you're not attending my classes and you come to me, guys, and you say, Awuti-san, how do you do a time code theorem proof? I'm not gonna help you. I'm not gonna help because you attend my classes, I give it in class with you. So guys, how was the session?
It was
It was
fine.
good.